Okay, now I want to talk about one-shot instruction in Allen Bradley's PLC. That's the next topic that we have to cover in chapter 5, which is about counters. Okay, what is a one-shot instruction? A one-shot instruction helps you to make your output active only for one scan cycle. So sometimes you have a signal like this, and then the length of your signal, what you have here, is longer than one scan cycle. But what you need is only one scan cycle. In this scenario, you need to use one-shot instruction. So one-shot instruction can be used whenever your input trigger does not release as soon as you need. An example is counter. Sometimes you want your counter reset instruction to be reset and quickly activate your counter again so your counter can start counting again. But the problem is that if your input instruction for your reset instruction is longer than one scan cycle, your counter will remain inactive or disabled while your input is active. Now we have different type of one-shot instruction. Some of them are sensitive to the rising edge. So some of them are sensitive to this. So whenever they see a transition from 0 to 1, then they will provide or create a pulse like this, and the length of this pulse is one scan cycle. Some of them are sensitive to falling edge. It means that they are sensitive to the transition from true to false. So this is what they're sensitive to, and as soon as they detect a falling edge or transition from true to false, then they produce the signal with the length equal to one scan cycle. Later, you're going to see in chapter 6 that you need this one scan cycle to avoid a lot of error that might happen because your signal is greater than one scan cycle, and you need to produce a signal with the length equal to one scan cycle. Now, there are different types of one-shot instruction. In Allen Bradley's PLC, we have three different types. We have ONS, we have OSR, and we have OSF. So ONS and OSR are sensitive to, both of them are sensitive to false to true transition. So you can see that both of them will produce your pulse, your desired pulse with one scan cycle length whenever they detect a false to true transition. And the other one, which is OSF, is sensitive to true to false transition. Now, what is the difference between ONS and the other two? The difference is that ONS is an instruction that comes between your input and output instruction. So for example, let's assume that you have some input instruction and you want to trigger an output, then this comes between them. So it means that this is your output, this is your input. So your one-shot instruction is not an output, it's not an input. It comes exactly in the middle of them. So whatever your input instruction is producing will be received by one-shot instruction, and then it will produce those pulses whenever it detects a rising edge. But OSR and OSF are output instruction. So if you look at here, both of them are output instruction and they don't have any other output instruction at the end of the rung. So they come at the very right end of the rung. So here you can see that this one is also output instruction. So these are the differences. Now you can see their application in the next slide. So here we have an input instruction, we have our output instruction. The counter reset instruction is an output instruction, and the one-shot instruction comes in the middle. So if you, for example, your part sensor here produce a signal like this, what happened is that this one-shot instruction is sensitive to false to true transition. So it is sensitive to this transition here, and because of that, it will produce a signal like this, which has a length of 1 scan cycle, and this 1 scan cycle is enough to reset your counter, and the counter will quickly go back to counting process, and it doesn't disable the counter, it just reset the counter, and the counter will go back to counting process and remain active. And in the next slide here, you can see OSR and OSF. So this is a one-shot instruction sensitive to rising edge. This is one-shot instruction sensitive to falling edge. Now, these two are output instruction. That's why you don't see any other instruction connected to them on the right-hand side. So they comes at the very right end of your rung, and you don't have any other instruction. And what happened is that when you feed this instruction with a particular signal like this, they will produce this pulse, and then you can use this pulse in the next rung to feed your output. So in order to implement something like this, you need 2 rungs. So you have to use the bits of your OSR and OSF in the next rung, and then you can feed them back to your output instruction. Okay, now the last part that I would like to cover in chapter 5, which is about counter, is going to be the preset value of counter. So if you remember from previous lectures, what we have for preset range is something between minus 32,000 something and up to positive 32,000 something. So, and that's because your preset value is one word, or in another word, 16 bits, and that's the range of number you can describe by 16-bit. Now the question is that, let's assume that I have an application that for my application I need to set my preset value on a number that is greater than my maximum positive number. For example, I need to have a preset value equal to 5,000. Now the question is that how I can do that if my maximum preset value is 32,000 something. Okay, the solution is cascading 2 counters together. How the cascading happens. So what you have to do is that you have to choose 2 preset. So you have to use 2 counter, let's say counter 1 and counter 2, and you are looking for a final preset value equal to 5,000. So you have to choose 2 counter that if you add their preset value, it's going to be 5,000. So what I'm going to do is that I'm going to set the first one at 30,000. Let's say, my bad. So the maximum that we can reach is 32,000 something. So the question is that if I'm looking for a preset which is more than this, so I'm assuming that this is 50,000, so I cannot cover it here. Okay, so this 50,000 needs to be provided by the preset value of my counter 1 and the preset value of counter 2. So I'm going to set the preset of counter 1 as 30,000 and the counter 2 as 20,000. So together that's going to be 50,000. Now how the program will look like. So what I have to do is that I'm going to use a sensor. Let's say this is, for example, a limit switch. And this limit switch is activating my counter 1. So I have C5 0 here, which is my counter 1. That's a CTU, and that's my counter 1. And the preset value is set to 30,000. Now, whenever this particular counter is done, I want to activate another counter. So whenever CTU, the first counter 1 is done, I want to activate another counter, which is my counter 2. So I'm going to use another CTU, which is located at C5 This is my counter number 2. And then the preset value is set as 20,000. And whenever the first one is done, it should activate my second counter. So here what I have is C5 0/done bit. Now, you might ask me why I'm not connecting these to my counter. The reason is that I need to add another instruction to both of these two wrong, and that's the close contact of the done bit of the counter, each counter itself. So here I want to use C5 0 done bit. At this point, you should know why I'm using this. So every single time that the limit switch detects an object, it will activate counter 1 because the done bit is 0 and I have continuity over this instruction. As soon as it reaches, the accumulator reaches to my preset value, which is 30,000, then my counter will be done and the done bit will be 1. The done bit will stop continuity here, and it means the counter here, my counter 1, won't be able to accumulate more than this. So the accumulator value will remain at 30,000. Now, as soon as this is done and the done bit is equal to 1, I have continuity over next wrong. So this time, counter number 2 is able to see the changes that happens in limit switch instruction. And I have to use the same instruction in the second wrong for counter 2, which is located at C5 So I have to use the done bit of the same counter, C5 done bit, just to make sure after it reaches to 20,000, it is not exceeding this preset value. So these two, that they have the done bit in close contact form of the same counter in the same wrong, what they are doing is basically they are preventing the accumulator value to exceed the preset value. But normally before reaching to that point, they bring continuity so they won't make any interruption. And this particular instruction, what it's doing is that it will activate the second counter as soon as the first one reaches to 30,000. So this way, the first one count the first 30,000 item, and then when it's done, the next one will be activated and it'll start counting. And if I want to know when 50,000 item has been counted, I can use the done bit of second counter to activate, for example, a red light or green light. So here I have to use C5 done bit to see whenever I have 50,000 item detected. Here you can see the program in a nicer